Welcome everyone. Welcome to the R session. Before we move into R, we are going to cover the setup part of R. We'll go about installing R and RStudio in our machine. I'm going to explain that. R is an open source, and to be able to install it, we should get the installer from CRAN. CRAN is the Comprehensive R Archive Network. It is the official website which maintains all packages of R. What it means is, as R is open source, you and I as individuals, we can create our own packages, and those packages we can submit to the CRAN. The CRAN, there will be set of people who will evaluate those packages, check whether there are any bugs or whether it's a malicious code, malified code. Okay. After doing the testing, if they require additional documentation and debugging to be done, they will revert back, and the individual has to resolve those things before it is officially available to people at large. That's how the packages gets contributed in R. So today there are thousands of packages. Okay. The official website is https://cran.r-project.org. So this is from where you should typically download your CRAN installer and no other place. In case you are using Windows, then I have directly given a link here. So what I'm going to do is click this link. Yes. So here I directly come on the Windows page. It shows me R 3.4.3 is the current version of R available. Or in case we just go to the home page, we can go there and download R for Linux, download R for Mac, download R for Windows. Whichever operating system you have, you can download the respective version. So R for Windows, base, contrib, all. What we have to download is the base. So I click on base and then I come to this part. And once I click it, it's going to start downloading the entire thing. What I'm going to do is cancel it. I already have it in my machine. As such, I'm not re-downloading it. Once you have downloaded it, the next step is to go about installing it. Installing is very simple. You have to simply double click on the exe file and follow the instructions it gives. Whether it will ask some instruction, whether you want to create a shortcut on the desktop, which folder you would like to install. So you give appropriate folder, or by default it will choose program files and it will go about installing there. Okay, it's a normal installation like any other software. After completing the installation, click on the version number, x64 or i386, which will be available in your start programs. For example, let me go to my start programs. Start, and here let me just scroll. So here you see there is R available. In my machine currently there are multiple versions, 3.1, 3.3, 3.4. So there are multiple versions. Probably each time there will be new version release, I would have updated my system. So i386 is for 32-bit and x64 is for 64. For example, now 3.3, 3.3 and 3.4. This is the latest one. So let me click this. So this is how your R interface would open, right? x64, as I mentioned, is 64, i386 is for 32-bit, and this is the console screen. Console is where you type your commands. Whatever programming instructions that you give is the place where you have to do the execution of those commands. Yes? Okay. When you install, the base package gets installed. If you see, I'll just go back. Here what we did say, base. Binary for base distribution. Minimum set of packages which are required with minimum functionalities. What are those minimum functionalities? For example, mathematical functions are required. Statistical package are required. Certain text manipulation function are required. Those minimum functionalities which are required comes along with the base installation. In case you want some additional functionalities, which are say a package by which you can do some modeling, say neural network, then you will require a package called neural net. The people who have developed those algorithms, they have created their own packages and then they have contributed to the R archive thing, right? Assume all the packages get downloaded while you're installing, then there are thousands of packages. Many of these packages are not required by you. Still, it will get downloaded and installed on your machine. So the R has given you the flexibility by which you can just install the needed package on your machine. Okay. So how do you install additional packages which you require depending upon your functionality? The command is install.packages. For example, I want data.table package to be available. So the way to go about installing data.table would be, I go to my console, I type install.packages double quote data.table, okay, enter. It is going to ask you from which CRAN mirror should I download. Basically, there are many servers or where these packages are available. The objective of that is to speed up the download process. So I'm saying, okay, I would like to take cloud HTTPS. I will go with the default one, okay, which is the starting one. So, okay. And then you see the package installation has started. You finally get package data.table successfully unpacked and MD5 sums checked. If this kind of a message you get, which means the package has been successfully installed, right? What I have done is, there are certain set of packages which we will be requiring for our sessions. And it would be some of the most used package by us. I've directly put a list of those packages. So what you can simply do is copy paste these packages in our console and execute them. These install commands you have to run one after another, or if you can simply copy paste them, then it will automatically keep running one after the other. Okay. For now, I'm not going to run all of these commands. But before I move forward, let me show you there are certain packages which you install from GitHub. I'm now focusing here on these packages. This package, GitHub. GitHub is a website where many people create their own projects. Okay, and on GitHub, people create their own packages, own utilities. Some of these utilities, those people would not have submitted to CRAN for bug fixing or for releasing it to the people at large. Not bug fixing, but for releasing those packages for people at large. They would have created their own package and they are using it from GitHub. To download those packages, you require a package which is called DevTools. You require a package called DevTools. The syntax is not install.package. It is now install_GitHub, which means GitHub is a place where many people who create their own projects and utilities, they are making those utilities available to people at large. However, those people don't want to go through the task of doing a detailed documentation, probably which CRAN requires, or those people would not have resolved the bugs which probably CRAN would have asked them, just in case they would have submitted to CRAN, or probably they would not have submitted it to CRAN at all. They are maintaining it on GitHub. Typically, you will see in companies allow access to CRAN. They will allow access to download packages from CRAN. Companies are not going to allow access to downloading packages from GitHub. Why? Because there is no one taking responsibility of the codes that you're going to download from GitHub. It is like I creating, say, some malified code and putting on GitHub. And probably you are just searching for something and that Google search is matching with my package and you come across my package. And you don't see how many people have recommended, how many people have not recommended. You directly download it. And if it's a wrong code, not a code which may harm your machine, you may end up downloading. So when you're downloading things from GitHub, you have to be very cautious. You have to see lots of things to ensure that, okay, this is a package which many people are using and many people have recommended on net. Only then download it. Otherwise, typically don't directly download from GitHub. Go with I would suggest CRAN website. Okay. So to download from GitHub, you require DevTools, which means you have to install the package DevTools. It might be already installed on my machine. Okay. If some package is already installed and you still run the install.packages command, that package will get again installed. It will overwrite it. Okay. By this command, there are multiple options available. I'm not going into those options, but the default is this. It is going to overwrite it. So let me just quickly run that command also. Package is installed on my machine, but I still cannot use that package. Now I'm talking about an important aspect of R. R is in-memory processing, which means all the processing when R is doing, all its component and all objects variables that you create are loaded in memory, and full object is in memory. So which means it is a memory heavy tool. For example, what it means is you have an object, a data table having of size 2 GB, and your machine has got only say 2 GB RAM. Some amount of that would have been consumed by operating system. This 2 GB object cannot be loaded. It will give you insufficient memory because it's a in-memory processing. As such, because R makes use of memory a lot, by default it does not load all packages. It is now your responsibility which package you require to load at that point of time. How to load a package in memory? By command library. When you run the command library, and you have to then specify the package name. So when you run this command library devtools, what it means, that package should now get loaded in memory. It says there's some warning message. It says it was built in this version, and I'm having a slightly older version probably, but the functionality will work. Now all functionality which is available in this devtools will be available for us. So probably in this there is a function called install underscore GitHub, as I mentioned here. Now I can run the install underscore GitHub. So whenever you are doing installation from GitHub, you have to ensure the library devtools command you have already executed. Okay. Having installed all of them, if you want to quickly do a setup check whether all packages have been installed properly, you have to try loading those packages in memory. Okay. For example, let's try library SAS7 BDAT. If this package is already in my machine, it will get loaded. It will not give any error. Error in library SAS7 BDAT because there is no package called SAS7 BDAT. Now, if you get this message, what does it mean? You have to install the package. If you want this package to be used, which means you have to install. So packages are codes which you as users would have written and made available to CRAN as a functionality. Probably that functionality is very important for many people. So here there is some package SAS7 BDAT. Probably if I want to make use of it, it does not get downloaded, installed by the base installation. So I have to, what I have to do? Install dot packages, and then I have to say SAS7 BDAT. So you see, it gets installed. Having installed, I still cannot use the functionality which is available in it. To be able to use a functionality which is available in it, what I have to do? Call library function and load that in memory. So, and here please note, I'm now not typing. I'm using my up and down arrow key. If I keep running up arrow key, all the commands which I would have run would come up. Okay, so latest command I run this one. Oh, sorry, I executed the same command again and it installed again. So yes, it installed again. So basically once you have installed it, don't run the command again. Otherwise it will install. There is no harm. It will install again. Only thing is, if the package is big, then it will take longer time. Right? So library. Now see, I did not get that error. Okay. So this is the concept of package. Functionalities are there in packages in R. And if you want a certain functionality to be used, you have to load that package in memory. To load it, the command is library. If the package is not installed in your machine, it will give error. And if there is an error, which means package is not available, you have to install. And the command to install is install.packages. Okay. There is an important utility available in R, which is Rattle. I'm not going to discuss at this point of time. Okay. You may do some Google search. What is Rattle? At this point of time, it would be too early to introduce that. But when you install Rattle, it will require some additional component, and that will get installed only once you call the Rattle function. Now, finally, the basic interface that you get for R is not that easy to keep working because it does not give you auto prompts. It does not give you a nice layout. Okay. There is a tool called RStudio, Beside RStudio, there are many other graphical user interface. But one of the most used graphical user interface to work with R is RStudio. Okay. So I would suggest that you should install RStudio also. The Studio installer is available at this website link which I have given. So let's quickly click that. It's going to take us to the RStudio website, and here you can choose your version of RStudio, which version you wish to buy. So you've got the RStudio for desktop. There is an open source license, free, and again there are commercial licenses, other things. For our training purpose, for our learning purpose, the desktop version is good enough. It comes with all the functionalities. Okay, you click download. So here it takes you what kind of download you want to have. You want Windows, Mac, Ubuntu, you want zip file or something. So those things are available. So if I say I download this, again the exe starts downloading. I'll pause and cancel it. I already have this installed in my machine. Again, the installation step is simple. It's a exe file. You have to double click and follow the steps and install. Let me quickly show you the RStudio interface. So I do RStudio. It is asking me to install the latest version. There's a available update available. I'm saying remind later. Okay. So here, this is how your RStudio would open. By default, this will also be empty. There will be nothing coming here. This would be something empty screen, and this will also be empty. I had already been using it, so old objects are coming up. This kind of a console you will get when you open RStudio. So what is there in this console? This part is your editor. The top, there is a 4 quadrant. Let me just divide it equally into 4 proportions. Okay, this part is your editor. Okay, what you do in editor, you typically type all your code here. Say a equal to 10. I'm just typing a simple code here. Enter. By pressing enter, code is not going to get executed. It is an editor. The code in R gets executed only in console. So if you want to run this code on console, this part of your screen is console. Okay, let's run this. I click the run button and it shows here. The code gets executed here. The moment this code is executed, you see in the global environment, it shows you A10. There is a variable A created and the value is 10. There are this part of this is editor, this is console, and this part, this quadrant where my mouse is rotating. Here there are 2 tabs. Environment. Environment shows what all objects are currently there in memory. As you keep writing command, say b equal to 20. Code is not yet executed. The shortcut is Control R. If you press Control R, the code gets executed in console. You need not always keep clicking run. Control R, b equal to 20 got executed, and a new object b having value 20 has been created, and you can see it is coming in the environment. All your new objects that you keep creating will go in the global environment. So here you can see there is a global environment. Some of the packages by default are already loaded. These are the set of packages which are by default loaded. Okay. Now this part, history. If you see all of these code, these are all my code which I executed probably before the session. So all of those history codes which I executed before this session is available here, which means when I shut down and restart my RStudio, these commands are still available. Let me just clean this. This broom kind of thing is to erase all history. I'm saying okay, erase. Now there is nothing in history. So what I'm going to do is again run this command, Control R, Control R, right? And that's where you keep doing this arrow. Now because there is nothing in, now I'm doing up and down arrow. On my laptop, I'm clicking on my up and down arrow because there is nothing beyond that. There are only two commands. It's just between those two commands. Now this part of the RStudio. Here it shows you file, plot, package, help, viewer. So basically file, what all files are there in my folder path, which is my working directory which I have already set. It's showing me the working directory which I have set for myself as a default. It is showing there. Plot. If you run any command which requires a graphical output, it will come in plot. Package. These are the various packages available in your machine which are already installed. In case you want to install a new package, you click on install. The beauty of the RStudio is now you don't need to remember the install.package command. So you can just do, but you should know the package which you wish to install. Okay, say I would like to install a package, say AOD. I type AOD. It automatically comes what are the different package available. I select that, install. Automatically install.package command has been executed on console, and see it gives me a warning, cannot open this, trying URL. Okay, finally it first gave a warning, it was not able to access it, but later on it has been able to access and this installation is done. Okay, again if there are some packages, if you know that there is an update version available, say I click here, the moment I click here, the library command of loading it is already done. The moment I do check here, detach, unloading happens. And now let's see the update. It will show all the packages which are available in my machine currently. Installed is 2.1-5, available is 2.1-6. And just in case you want to update that, I click here and say install updates. The reason why this a equal to 10 keeps coming is because this was already typed there. Okay, otherwise there is no reason why a equal to 10 keeps coming. Okay, so after installation, whatever the command was already typed, it keeps showing that command. Okay, so and again you keep see in history all the syntaxes that I have been executing are coming here. All these things are necessary basically before you work. You should know the environment, right? So we are just trying to understand how this tool works, right? We created a variable A, we created a variable B. Did we create, say, a variable pi? Pi is a constant. Value is 22 divided by 7. We know area of a circumference of a circle is 2 pi r. Area of a circle is pi r square. We know, and that pi. In my command, I created variable A and variable B, but I did not create pi. At any given point of time, if you want to know the value of a variable, you just type that either on editor and say click run, or you can directly type it on console and run. Here please note, I've created variable A. I've not created small a, I created capital A. R is case sensitive. R is case sensitive. So if you type small a, it is going to say error. Error A, object not found. Likewise, did I create this variable pi? I did not. So if I run this command on console, what message it should give? Let's run that. It gives you. Why? Because pi is a mathematical constant. So it has to be available in some of the base packages which relate to mathematics, right? It has to be there. It is available in stats. To my knowledge, it is part of stats. It should be part of the stats package. Let's just see that question mark. If I run that, when I run question mark pi, I get the help. Okay, it's saying it's part of base package. It's part of the base package. And what gets loaded by default? Base. So anything which is there in the base is available. Are you getting? Certain package by default gets loaded. It's available. And how did I, at any given point of time, if you want help on anything, again, when you're using a tool, getting help on the tool is an important thing. The way to get help is question mark and the function which you want help on, or the variable on which you wish to have help. So here pi is an inbuilt thing which is on base. So here in the help documentation, you get the entire details. So here you can keep reading. So the documentation will show you all the details. And it says it is a built-in constant. Everything in R gets stored in some namespace. Everything in R gets stored in some namespace. So pi is stored in the namespace base. Okay. Now if I type pi is equal to 3.14, I just type it this much. I just typed pi is equal to 3.14. Control R. It got executed on the console. Now if I run and try to find out what is the value of pi, what it should display? Should it display 3.141593 as it in this syntax? Here? Or it should display just 3.14? Okay. Now when you are going to run pi, it is going to display 3.14. Okay. So here comes the concept of namespace. In normal programming languages like Java, you cannot override constants. You cannot override constants. But here I'm not actually overriding the constant. Here the concept is of namespace. The sequence in which the variables will be searched. So if when I type search, enter. When I run search, enter, you see the sequence in which the search will happen. The first element here is what? Global environment. if you see our global environment, a pi got created and the value is 3.14. Then comes a package which is RStudio, then comes stats, then come graphics, then come GR devices, then utils, then datasets, then methods, then autoloads, and then base. So basically, what happens is when I'm now running a command pi, it is first searching in global environment. If it finds pi available in global environment, it gives you 3.14. If it would not have found a pi, and that's what happened earlier, it went to RStudio. It did not find here. Then it went to stats, then graphics, GR devices, utils, dataset, methods, autoloads. None of these places it found pi. It finally found it in base and finally it executed. How do I now get the pi which is in base? Basically, if there is a requirement that you have to still access the pi which is in base, because that's a sequence. How do I do that? The way to do is base colon colon pi. So here I'm now saying that please directly go to this namespace, this package, and get it. So when I run this, I'll get 3.141593. So here what we are trying to understand is the interface. This is your editor. This is your console. Here there is an environment. There is a history. In environment, it is showing you what all packages are already there, installed and loaded, not just installed, but also loaded. This part is to show files from your default directories folder path. Plots, any graphical plots you're going to create will show packages, help, viewer. There are certain outputs, specific outputs on which you can probably dynamically play around. It's not just a plot, but there are certain outputs where, for example, pivot table kind of output, where you can play like a pivot table, you do drop row, columns, and all those things. In that case, it comes in a viewer. If you see all of these things is not available in your basic version, does it show what all objects are there in memory? No, right? RStudio as a graphical user interface is much more easy. Just in case you have to work on the basic interface, what I would suggest is do not typically type your commands directly in console. The basic interface also provides you an editor. This is the editor. So what you do is you also type here only a equal to 10, just like we were typing the commands. If you wish to run the code, Control R. Control R, the code gets executed on the console. B equal to 20, Control R. And you want to see what is the current, say C equal to A plus B, Control R. And you want to see what is the value of C. Either you type on editor, Control R. My suggestion is whenever you are working, always run your code in editor. Never directly run your, always type your code in editor. Execution anyways you have to do on console only. Always type your code in editor. Why? Because this file you can save. When you save, you can give say name ABC, and the default extension of this file is .r. R files are saved as abc.r. .r is the extension of a R script file. .r is the extension of .r is the extension of our script file. So you can save it, and once you have saved it, for example, after saving, you close the session and you restart. You want to open that file, you can open and you can get the entire code. Okay. And second important thing is help. Any given point of time you want help, you should know that the command is, say I want a help on a function, get wd. Here when I do, it opens in a browser. On the basic interface, if you do, it will open in the browser. Whereas if you do it in RStudio, it will open in this pane. The other way to get help is this way. You have a help function, you type the function name in it, run it, and you can get the help. So basically this is a quick introduction to R1 setup and basic interface of the R interface which comes by default and R interface which comes with RStudio. For our session, we'll constantly be using RStudio. For a very simple reason, it is very handy. Again, there are features like auto prompt. I just type get, it just gives me idea, and see here it mentions this part. It says it's stats package, base package, methods package. Besides that, it keeps giving you the documentation also, right? So here get wd, get wd returns an absolute file path representing the current working directory of the R process. Set wd dir is used to set the working directory of the directory. So if I run this command, get wd, enter, I just have to, I did not type the full thing, I just pressed enter. It typed the auto completed it, Control R. It shows me my default directory is this path. So these are the benefits of using this RStudio. So our entire session will be doing it on RStudio. So just ensure when you come for the next session, you have R and RStudio installed. And as I mentioned in the presentation, certain packages, these are the set of packages, install and execute them. Will require them at a later stage. Once we have already installed, then we need not install it again. How to check whether the packages have been installed? Run the library command. So those packages will get loaded. If they fail to load, which means there's some, you don't have it. As simple as that. And the RStudio version, whichever is the latest version, you can download it from the RStudio website. With this, we'll end today's session. Thank you. See you next time with the proper installation of R and RStudio. Bye.